Welcome learners to this presentation titled as Education as a Vehicle of Scientific and Technological Development. The three key words in the title are education, which is preparation for life, scientific, which deals with systematization, and technological development. Technology related to the recent advances of technology in education and technology of education. With this percept, this presentation explores the integral relationship between education and the development of science and technology, highlighting the importance of a well-rounded educational framework that promotes critical thinking, creativity, and practical application. Let us take a look at this visual. This is the educational cycle of innovation. Since this is a cycle, it has various phases. Build knowledge and skills. Education equips individual with the necessary knowledge and skills. Foster critical thinking. Education encourages critical thinking, essential for innovation. Encourage creativity. Creative thinking leads to new ideas and solutions. Promote practical application. Applying knowledge in real-world scenarios drives progress. Contributes to innovation. Innovations lead to advancements in science and technology. So this cycle of innovation is educational in nature. Let us explore and analyze with the first question. How does the well-rounded educational framework depicted in the visual specifically translate into curriculum design and pedagogical practices? The next question, which also refers to the visual. Beyond knowledge and skills, what other critical attributes does education cultivate that drive scientific and technological advancement? Analysis to question 1. How does the well-rounded educational framework depicted in the visual specifically translate into curriculum design and pedagogical practices? How is this possible? We are going to discuss the various possibilities towards translating into a curriculum design and pedagogical practices towards creating well-rounded educational framework. Curriculum design through an interdisciplinary approach. Moving away from siloed subject to integrated learning experiences that connect science, technology, engineering, arts, and mathematics, popularly known as STEAM. Let us take an example. A project on sustainable cities could combine science, that is environmental impact, technology, smart infrastructure, and art, design, and aesthetics. This is a beautiful example of interdisciplinary approach. Emphasis on process over content. How is it possible? By prioritizing the development of critical thinking, problem solving, and analytical skills over rote memorization of facts. Curricula designed to encourage inquiry based learning, where students explore questions and discover answers through investigation. Real world application, integrating practical experiences like laboratory work, field studies, and internships to connect theoretical knowledge to real world problems. Incorporating project based learning that requires students to apply their skills to solve authentic challenges. These skills include creative, critical, and innovative thinking. Ethical considerations. While designing a multidisciplinary or interdisciplinary curriculum, ethical considerations are also to be kept in mind, including curriculum that allows students to understand the ethical ramifications of scientific and technological advancement. Now, with this, we got an idea of interdisciplinary approach in designing a curriculum towards creating well-rounded individual. Now let us discuss the pedagogical practices. Inquiry-based learning. In this practice, teachers acting as facilitators, guiding students through investigations and encouraging them to ask questions. In this practice, classroom environments are created to foster curiosity and exploration. Another practice, collaborative learning, promoting teamwork and communication skills through group projects and discussions. Encouraging peer learning and the sharing of diverse perspectives. Technology integration. Using technology as a tool for learning, not just as a subject. Leveraging digital resources, simulations, and online platforms to enhance engagement and understanding. Differentiated instruction. This is another pedagogical practice. Tailoring teaching methods to meet the diverse learning needs of all students. Providing opportunities for students to learn at their own pace and in ways that suit their individual learning styles. Now we come to analyzing question number 2, which was again based on the visual education cycle of innovation. Question 2, beyond knowledge and skills, what other crucial attributes does education cultivate that drive scientific and technological advancement? Now, what are the crucial attributes beyond knowledge and skills, as asked in the question? First one is a critical thinking. What is it? The ability to analyze information, evaluate evidence, and form sound judgments. Creativity and innovation. It is the capacity to generate new ideas, think outside the box, and develop innovative solutions. Problem solving. Ability to identify and define problems, develop strategies, and implement solutions. Communication and collaboration. The skills to effectively communicate ideas and work collaboratively with others. We are getting other attributes beyond knowledge and skills that can cultivate and drive scientific and technological advancement. So these are the crucial attributes beyond knowledge and skills. It continues adaptability and resilience, which is beyond knowledge and skills. The capacity to adapt to changing circumstances and preserve through challenges. Ethical reasoning. The ability to consider the moral implications of scientific and technological advancements. Curiosity and lifelong learning. This is a natural desire to learn and explore, and a commitment to continuous self-improvement. This leads to sustainable growth. Now let us ponder over these points. Let us ponder on the attributes beyond knowledge and skills that can foster and cultivate scientific and technological development. By fostering these attributes, education can empower individuals to become not just knowledgeable professionals, but also innovative thinkers and responsible citizens who can contribute meaningfully to scientific and technological progress. So, education is cultivating through interdisciplinary approach of curriculum design and varied pedagogical practices towards well-rounded individuals who can contribute meaningfully towards the scientific and technological progress. This visual, which is up on the screen, reflects how can we build scientific foundations. How is it possible? There are three blocks. By basic knowledge, which forms the foundation, rests on it is advanced studies, and at the top is the future innovators. And the role of education in scientific development is to equip individuals with the essential knowledge required to understand complex scientific concepts. Through structured curricula, students are introduced to fundamental principles of science, which serve as the building blocks for more advanced studies. And this foundational knowledge is crucial for nurturing the next generation of scientists and researchers who will drive future discoveries and innovations. Cycle of inquiry-based learning as one of the best pedagogical practices that can instill to develop critical thinking skills, foster curiosity, engage in problem solving, conduct experiments, and encourage questions. So these 5 phases of the cycle of inquiry-based learning is crucial towards well-rounded individuals contributing towards scientific and technological development. Education encourages inquiry-based learning, where students are motivated to ask questions, conduct experiments, and engage in problem solving. Such hands-on approach not only enhances their understanding of scientific methods but also fosters a sense of curiosity and a desire to explore the unknown. As students engage in research projects and collaborative learning experiences, they develop critical thinking skills that are vital for scientific exploration. How technology integration in education can foster the culture of creativity, innovation, progress, and development. The integration of technology in education has transformed the way knowledge is imparted and acquired. Digital tools and resources provide students with access to vast amounts of information, enabling them to explore topics beyond the traditional classroom setting. Examples: online courses, virtual labs, and interactive simulations enhance the learning experience, making complex scientific concepts more accessible and engaging, thereby maximizing the learning outcomes of the students. This is how the visual represents how education is enhanced through technology. In a nutshell, it is through digital tools, that is, devices and software used for learning, online courses, educational programs accessible via the internet, virtual labs, simulated lab environments for experiments, and interactive simulations, engaging models to understand complex concepts. Enhancing education through technology. How is it possible? Apart from its varied, nuanced contribution, technology facilitates collaboration among students and educators across the globe. This interconnectedness allows for sharing of ideas and resources, fostering a culture of innovation. As students work together on projects using digital platforms, they eventually develop essential skills such as teamwork, communication, and adaptability. These are the qualities which are crucial in the rapidly evolving landscape of science and technology, and how beautifully education connects this scientific and technological development. How does education prepare future innovators? Let us take a look at the visual of cycle of innovation in education. By imparting knowledge, cultivating creativity, fostering entrepreneurship, encourage risk taking, and support passion pursuit. These are the attributes towards preparing future innovators. To ensure that education continues to serve as a vehicle for scientific and technological development, it is essential to focus on preparing future innovators. This involves not only imparting knowledge but also cultivating skills that promote creativity and entrepreneurship. Educational institutions should encourage students to think outside the box, take risks, and pursue their passions in science and technology. As a vehicle, education is bridging educational institutions and the industry. It is promoting academic industry interface by collaborative research initiatives, mentorship programs, and internships. Additionally, partnerships between educational institutions and industries can provide students with real world experiences that bridge the gap between theory and practice. Activities like internships, mentorship programs, and collaborative research initiatives can inspire students and give them a glimpse into the practical applications of their studies. By fostering an environment that values innovation and experimentation, education can empower students to become leaders in scientific and technological fields. The visual is a beautiful depiction of education's role in technological development. As a cyclic phenomenon, it has lay groundwork, that is, establishes foundational knowledge, the very first stage or the core. Next, promote critical thinking, encourages analytical skills, integrate technology, enhances learning experiences, prepare innovators by fostering creativity and collaboration, drive progress, advances science and technology, and benefits society, provides societal advancements. This is how education's role in technological development proceeds in a cyclic manner. Let us watch a short video.
The future of education can't be found in a gadget or an app or a program or a product. It doesn't require a think tank full of pundits. No, the future of education can be found in your classroom. Your classroom is packed with creative potential. You have all the innovation you need right there in your room, and you have the power to make it happen. It's what happens when you experiment. It's what happens when you give your students voice and choice. It's what happens when you abandon the scripted curriculum and take your students off-road in their learning. It's what happens when you teach to your students rather than teaching to the test. It's what happens when you unleash the creative power of all of your students, when you make the bold decision to let them make things and design things and solve problems that they find relevant. Sometimes it's messy and even confusing. It often looks humble. But understand this, that every time your students get the chance to be authors or filmmakers or scientists or artists or engineers, you are planting the seeds for a future that you could never have imagined on your own. That's the power of innovative teachers. That is why the future of education is you. Hey, if you enjoyed this video, I encourage you to subscribe and to like it and to leave a comment about something innovative and creative and amazing that you're seeing in your school or in your classroom or in your child's classroom.
We have come to the end of this presentation. Let us have a quick session summary. Education is a vital component of scientific and technological development. It lays the groundwork for understanding complex concepts, promotes critical thinking, and integrates technology to enhance learning experiences. by preparing future innovators and fostering a culture of creativity and collaboration. Education can continue to drive progress in science and technology, ultimately benefiting society as a whole. As we move forward, it is imperative to prioritize and invest in educational frameworks that support these goals, ensuring brighter future for generations to come. Based on the discussion, here are few questions of short answer time. What is the primary role of education in relation to science and technology? What two specific attributes does the session emphasize that a well-rounded education promotes? What does the presentation suggest education serves as for individual knowledge and skill development? What is the session's view on the overall impact of education on innovation? What kind of application is highlighted as important in educational frameworks? According to the session deliberation, what is a key element of a successful educational framework? All these questions are thought-provoking, and I'm sure the discussion will help you all to answer them in your own ways and views. Let us watch a short video.
What is STEM? STEM is not just a subject at school. It's a way of thinking and doing, and an important skill set that could see your generation working together to solve some of the world's greatest challenges. STEM stands for science, technology, engineering, and mathematics. But it's not about being an expert in all of those things. Instead, it's about harnessing the essential, transferable skills behind them. Scientists know how to hypothesize, experiment, analyze, and evaluate what they discover. Technology can make our lives better. Designers of all sorts work together to make everyday tasks more effective and more fun. Engineers don't just wear hard hats. They are problem solvers that work on some of the world's biggest challenges, like creating bionic limbs for people with disabilities or exploring outer space. Mathematics teaches us how to quantify data and how physics rules the world around us. With mathematics, we can implement change and minimize error. You won't have to master all of these skills either. Teamwork is an essential STEM skill. Take the search for new energy sources, for example. Geologists and geophysicists search for gas deposits. Engineers help you design and run platforms and processing plants. Construction teams work to build essential infrastructure under the supervision of project managers, and environmental scientists work with everyone every step of the way. Playing to your strengths and working in a team will have you creating a greater impact than if you were working alone. It would cost the Australian economy $9.3 billion in lost productivity, profitability, and employee satisfaction. STEM skills are useful to almost every career. 75% of today's fastest growing careers require STEM skills, and 82% of today's employees say they value STEM skills even if they're not required for the job. STEM skills can even unlock your potential to earn a higher salary or become more employable. You don't have to earn a university degree in STEM to be successful either. There are plenty of courses to get you started in STEM. But we don't have enough STEM graduates to meet demand. Numbers show the demand for STEM careers has grown 79% since 1990, but enrolments in STEM degrees are at an all-time low compared to the last 20 years. And despite the job opportunities, just 16% of STEM professionals are women. STEM careers can start small, then change the world. Engaging in your high school STEM classes or learning to code could be your first step to delivering driverless vehicles to the roads. Starting a research project at home or entering a science competition could see you defeating cancer with a cure. And that's just the beginning. We don't yet know what kind of jobs will exist 10, 20, 30 years from now. But with STEM, you're prepared for anything. How will you shape the future with your STEM skills?